In this video, we're going to complete numbers 3 and 4 from the Unit 4 Day 3 notes about limacons. So you should be watching this after you've done the GeoGebra exploration. So here we have, we want to summarize some things. So when will the equation manifest into a dimpled limacon like number 1? That's the first graph that we made. So a dimpled limacon, I'll just draw a picture. That's going to be something like this for the cosine one. The same thing would be true for sine. It would just be vertical. So there are some rules, but I'm not a huge fan of memorizing the rules because I think it's easy to forget them. So what I like to do if I'm facing a problem like this is I like to make a sketch of the graph in the Cartesian plane. So let's say these are our axes, and we're graphing r equals a cosine theta plus d, which means that we're going to have the midline is going to be at y equals d, and then the amplitude means we'll go up a units, so this would be d plus a, and down a units, so this would be d minus a. And if it's a cosine graph, it'll start, let's say a is positive, it'll start at a maximum, and we'll have a graph that looks like this. When we have a graph that looks like this, the graph in the Cartesian plane never crosses the x-axis. So never crosses x-axis. When that's the case, we never have any negative r values. So no negative r values, and that's when we have the limacon with a dimpled limacon. So this is the way I would summarize it. So if the graph in the Cartesian plane never crosses the x-axis, we have a dimpled limacon, okay? So we have a dimpled limacon because it's always positive. R is always positive or always negative. And if you want a rule to memorize, this happens when the absolute value of A is less than the absolute value of D. That means that when we subtract A from D, we're not going to cross the x-axis. Okay, when are we going to have a cardioid? So let's take a look at that. So in the Cartesian plane, we're going to have a cardioid when the graph just touches the x-axis, but doesn't cross it. So we're going to have something that looks like this. Let's say it's always positive. It could also always be negative. Right, or we could have something that looks like this. But it's never crossing, it's just touching the x-axis. So when will the equation manifest into cardioid like number 2? That's going to happen when the graph in the Cartesian coordinate plane just touches the x-axis, but it doesn't cross. And that happens when A is equal, the absolute value of A is equal to the absolute value of D. And if I were to put my midline on, and this would be y equals D, and then the maximum would be at D plus A, would be the maximum, and the midline would be D minus A. And that would be right at y equals 0. Okay, when will the graph manifest into a looped limacon? So the looped limacon is going to occur when the graph crosses the x-axis in the Cartesian plane. So this will happen in the Cartesian coordinate plane. The graph lies both above and below the x-axis. So I'm going to make a little sketch of what that looks like. So here we'll have something that's actually crossing it. So we could have something like that, right? And when is that going to happen? When we're going to have something that crosses, that's going to happen when the absolute value of A is greater than the absolute value of D, right? Because in this case, I'm going to draw a different graph here and make it a little more obvious and a little more explicit. So let me draw in the x-axis. Let's say that our midline is here at y equals d, and let's say we go up a units and down a units. So we're going to go here. This would be d minus a, and then we can sketch our graph, and we'll see that now, because the absolute value of a is greater than the absolute value of d, so when we subtract a from d, we're going to go beneath the x-axis. And we can have it going where it's primarily negative and then going a little bit positive. But as long as it goes both above and below the x-axis in the Cartesian coordinate plane, that's when we get the limacon with an inner loop. And that happens because we are getting some negative r values. So when it crosses, it means we get some negative r values, which is when we get the inner loop, right? So this is which gives us the inner loop. Or if it's primarily negative and then goes positive, that the positive part would be the inner loop. Okay, so this isn't 100% correct. It just means when r changes sign. So when r changes sign, we get an inner loop. All right, so that's number 3, summarizing. And now let's try number 4. So number 4 is a matching exercise. So we're given equations, and our goal is to match them to graphs. So before we look at the graphs, I want to try to analyze each one of these. So we have r equals 2 cosine theta minus 1. Since it's cosine, that means it's going to be horizontal, and if it's positive, this will be mainly to the right, right? So this is horizontal, mainly to the right. And now we have to decide, is this dimpled, is it a cardioid, or does it have an inner loop? So what I would do is I would make a quick sketch of the graph. So we know that the midline is going to be at y equals negative 1. And then the amplitude is 2. So we're going to go up 2 units and down 2 units. So y equals negative 3 and y equals 1. And I can already tell this is my skeleton for my graph of my cosine graph. So I can tell that the graph is both positive and negative. So this means that we will be horizontal, mainly to the right, and it will have an inner loop. So we know that. And the maximum, we know the maximum and the minimum. So we've got the point 0, 1, and then we would have the point pi negative 3 on our graph. So let's look at the graphs on the next page and see if we can find this one. So we need and this first one is going to be f. Okay, let's look at the next one. R equals cosine theta plus 2. So I would make a sketch. You can also look at the a and d values if you like that. So here we know that this is horizontal to the right because a is positive. And now we need to know what this form is. It's a dimpled inner loop or a cardioid. So I would make a little sketch. So the amplitude is 1. And the midline is at y equals 2. So we have y equals 2. We're going to go up 1 and down 1. So this graph is always going to be positive. So this is a dimpled horizontal limacon primarily on the right side. Okay, so let's say previous page. So this is A. Let's do the next one. 2 cosine theta plus 2. This is easy. It's easy to see if we have a cardioid. When A equals D, the absolute value of A equals the absolute value of D, we have a cardioid. It's not really necessary to graph this one. This is more obvious. So this is a horizontal cardioid, mainly on the right. So let's go to this is C. Okay, so for the next graph, we have -3 sine theta plus 3. Once again, we can see right away that this is a cardioid, and it's going to be vertical. I know it's a cardioid because the absolute value of A equals the absolute value of D. A vertical cardioid, and because A is less than 0, this will be mainly downwards. So let's see if we can find that graph on the next page. So I'll label this. This is B. The next one, we have -3 sine theta minus 4. So we know it's vertical. It's downward. And now we want to see if it's dimpled or inner loop. It's not cardioid because the absolute value of A is not equal to the absolute value of D. So let's make a quick sketch. So here, D is -4. So the midline is y equals -4. The amplitude here is 3. So we're going to go up 3 to y equals -1 and down 3 to y equals -7. This would be a sine graph, so it started at the midline. It's negative. It's going to go down. So that would be our graph. So this is always negative. It doesn't cross the x-axis. So we know that this is a dimpled vertical limacon. So let's look back and see if we have a dimpled that in on the other page. So this was E. And the last graph, -3 sine theta minus 2, we could find it by elimination, process of elimination, but let's go ahead and think about it. So since it's sine, it's vertical. Since A is negative, it's going to be mainly down. And now we have to decide, is it dimpled or does it have an inner loop? So I would make a quick sketch. So this is D is -2. So I draw a line at y equals -2. That's the midline. The amplitude is 3. So I'd go up 3 to y equals 1 and down 3 to y equals -5. This would be a sine. It starts at the midline and goes downward. So it's going to look something like that. And since it's crossing the x-axis, so this crosses x-axis, this it's a vertical, mainly downward limacon with inner loop. So let's make sure the last graph, that is D. Horizontal limacon, mainly to the right side with an inner loop. So this is our only option. So this is letter F, right? So this is going to be our first equation. So this was R equals 2 cosine theta minus 1. And we can actually see the minimum value here is at pi. This is pi -3. That's that point. And then we had 0, 1. Those were the 2 points we found. But we don't really need that actually to just do the matching. So let's go back to the previous page. So we want a dimpled horizontal limacon primarily on the right side. So that would be letter A. That would be our only option. So this is R equals cosine theta plus 2. And I will go back and see if we can find a horizontal cardioid mainly on the right side. And that sure looks like C to me. If you wanted to, we could check some points as well. So this is r equals 2 cosine theta plus 2. What happens when theta is 0? When theta is 0, cosine of 0 is 1. So at 0, we should be at 4, which we are. So this is the right graph. None of these other ones have the 0.04 on them. Okay, so let's go back. So we said we needed a vertical cardioid, mainly downwards. So that would be graph B. So this is r equals -3 sine theta plus 3. Limacon mainly downward. We're almost done here. So this sure looks right. Dimpled vertical, Limacon mainly down. So this is r equals -3 sine theta minus 4. And we can see we have this point down here at 7, which is what we would need. That would be the minimum. It's actually pi over 2 -7. So if we were checking points, this is pi over 2 -7, which works on the graph. So corresponds. So the last graph is letter D. So this one right here. So it's vertical, mainly downward, and it does indeed have an inner loop. So this would be r equals -3 sine theta minus 2.